Hello everybody, my name is Shankarji. Now we will be discussing chapter 13, Fun with Magnets. What do you mean by magnet? Magnets are objects which attract certain kind of other objects towards them. Normally they are iron based. Magnets are normally iron based. We can also call them ferrous. Ferrous based materials are magnetic in nature and non-ferrous materials are not magnetic in nature, because if you look at certain elements, metals like iron, nickel and cobalt, they have the property of magnetism in them. They can attract other iron particles or nickel particles or cobalt particles towards them. However, non-ferrous materials cannot pull other materials towards them. Like say carbon cannot pull other carbon when the carbon is sitting right next to each other. But if iron piece is magnetized, if it has been converted to a magnet, and if you keep another small piece of iron, they will attract to each other. So the magnet will pull the iron piece towards itself. So that's why this is known as magnetism. There are only four forces in the universe. One is the force of gravity, gravitational force. One is the electric force. One is the magnetic force, and another one is the nuclear force. So wherever there is electricity, there is also magnetism. Electricity and magnetism, they always go together. So that's why they are sometimes known as the electromagnetic force, also known as the EMF force. So now we are going to study with magnets. Magnets are objects which are using the magnetic force. A few examples of the magnetic materials, also known as the ferrous materials, are iron, Fe, nickel, Ni, cobalt, Co, etc. A few examples of non-ferrous materials are wood, plastics, rubber, etc. What about the magnet? I mean, what does a magnet mainly consist of? Magnets can be of various shapes and sizes. It can be like a bar magnet, it can be like a chocolate bar, it can be like a round magnet. It can be of various shapes and sizes, but nevertheless, all the magnets have two things in common. One is they always have something known as the poles of a magnet. That's what makes a magnet. All magnets, irrespective of their shapes and sizes, will always have two poles, the north pole and the south pole. This is absolutely essential for a ferrous material to become a magnet. For example, if you take a bar magnet, we are considering a magnet which is in the shape of a chocolate bar. So it has a north pole, it has a south pole. So the magnetic field lines will always travel from the north pole towards the south pole. The important thing to be considered over here is like poles repel each other and unlike poles attract each other. What I mean by that is, if I keep a bar magnet in this format like north-south, and if I bring another bar magnet with the north pole like this, so what happens? One bar magnet has south pole and another bar magnet has north pole. So they will be attracted towards each other. However, if I turn the direction, if I keep north and north, they will repel each other. Same situation is possible when south and south also, if I come face to face with each other, they will repel each other. Only when north and south, when they face, they attract each other. So like poles repel and unlike poles attract each other. This is the basic law of magnetism. After that, we come to something known as a magnetic compass. Suppose if you want to go in the woods, deep in the forest, and you don't know which direction you want to go. So how will you find the right direction? So that's why we have a wonderful device which is known as a magnetic compass. It's also available in wristwatches. If you can get some wristwatch with a magnetic compass attached, that's also wonderful for finding the direction. But no wonder when you can find the direction with the direction of the sun, but on rainy days or on dark days, how will you find the correct direction? So that's why you need a device known as a magnetic compass, which is an instrument. So magnetic compass has nothing but it has a magnet which is fully attached to a spindle. It just fully rotates. So if you take a magnetic compass and just keep it in your hand, after a while it will align itself in a north-south direction. The reason why the magnetic compass aligns itself in the north-south direction is because our Earth, our planet Earth itself is a giant magnet. What a wonderful thing. We are living on a giant magnet. So if you look at the Earth, we have a geographical north. But as we all know, the Earth is slightly tilted on its axis. So we also have a magnetic north and south. So the difference between the geographical north and south and the magnetic north and south is known as declination. There's a small angle, theta. It's known as declination. So what happens is, when you keep the magnetic compass in your hand, or maybe if you keep it on the ground, anywhere on Earth, the north-south magnetic field lines of the magnetic compass and the Earth, they synchronize with each other, and therefore you get the north-south line. And when the north-south direction is is obtained, you can easily find all other directions, and you can enjoy your trekking, and you can complete your adventure. Apart from that, we also have a wonderful star which has been guiding humanity for ages, for centuries. That star is known as the North Star, also known as the Pole Star, also known as the Polaris, because that is the only star which is available in the visible sky, which is always fixed. If you look at the North Star, it's just there on the north hemisphere, and all the other stars rotate around it. It never rotates. It's always fixed. That's why it's one of the few stars which is just fixed. For humanity, only North Star has been guiding for so long, for so many centuries. Suppose if you're not on land, if you're on sea, and if you're on a ship or a boat, and then you're at night, then how will you know the directions, even if you don't have a magnetic compass? So then you look for the North Star, and based on the North Star, you find the north-south direction, and then you can navigate accordingly. You can go east or west. Now, can we take a piece of iron or steel, and can we make it as a magnet? Yes, we can. And can we take a magnet and can we make it as a normal iron material without the magnetic effect? Yes, we can. So the process of converting a ferrous material, it can be iron, nickel, cobalt, into a magnet which attracts other ferrous materials, that is known as magnetization. And the process of converting the magnet, the ferrous-based magnet, into a normal ferrous material without the magnetic effect, that is known as the demagnetization. So yes, we can magnetize and demagnetize ferrous materials accordingly. That's why it's known as magnetization and demagnetization. However, non-ferrous materials cannot be magnetized or demagnetized because they have got nothing to do with magnetism or electricity, because they are insulators. Suppose if electricity is like that, magnetism will always be surrounded by it. So electric field will always be surrounded by the magnetic field. That's why they are combined force. Wherever there is electricity, there is magnetism. So non-ferrous materials, they don't have any magnetic properties. So we have discussed magnetization, demagnetization. Speaking of that, what are the applications of magnetization and demagnetization? The main thing is we can create temporary and permanent magnets. You might have seen in your radios or TV, if you disassemble it, you will find a magnet in between. So the magnet can be used as a speaker. So it's nothing but it's a permanent magnet. How do you magnetize? How do you magnetize a ferrous material? You take a piece of iron and you pass the magnet from north side to south side. From the north pole, if you pass the current from north pole to south pole in one direction, it will become a magnet after some time. And if you want to remove the magnetic effect, if you want to demagnetize it, you have to pass the current in the opposite direction, from the south to the north. So the magnetic field will be removed. So in this way, you magnetize and demagnetize ferrous objects or iron-based objects. What are the advantages of temporary magnets? They are also known as electromagnets. When you turn on the electric current, it becomes a magnet. And when you turn it off, it becomes a normal material. That's the biggest advantage. You can turn it on, you can turn the magnetic effect on and off, which is not possible in a permanent magnet. So that's the biggest advantage of electromagnets, also known as temporary magnets. Let me just recap this chapter. So magnets are objects which attract certain kind of other objects, mainly ferrous, iron-based materials. Non-ferrous materials, they got nothing to do with electricity or magnetism. However, they are also very useful in blocking electricity. An electrician has to work on dangerous circuits, so he or she can protect himself or herself with the proper electric gloves or with the proper rubber boots and work safely. So yes, they are also absolutely important. And then we discussed the poles of magnet, the north-south poles, the magnetic field lines. They always flow from the north to south pole. And we discussed the geographical north. We discussed the magnetic north. We discussed the declination, the angle of difference between the magnetic north and the geographical north of the Earth. And the Earth itself is a giant magnet. And we discussed the process of magnetization and demagnetization. We discussed about the North Star, also known as the Pole Star, also known as the Polaris. And we discussed the 8 directions, the 4 cardinal directions, north, east, west, south, and the 4 other directions, north, east, southeast, southwest, and northwest. And finally, we wrapped up, we discussed temporary and permanent magnets, and we discussed the applications of permanent magnets and temporary electromagnets. So if you have any doubts or suggestions, please let us know in the comment section below. Thank you so much. Have a good day.